Well, this work actually started with our teaching at BC. We arrived here at the same time, actually, to teach the same class. So we came to teach the history and philosophy of science class, among other things, but with a mandate that we should be teaching a year-long course, sort of Plato to NATO, double credit, history and philosophy of science. And we sort of thought that when we would start teaching this class that we would look for like sort of the collected works reader, the standard one in the field that would cover all the material, and we just order that and get started. That didn't work so well.
Yeah, so we began just piecing together our own course material from existing collections that might focus on, say, Copernicus to Newton, but trying to find something that would span the range of historical texts that we were looking to cover, ancient world to the end of the 19th century, that would cover not just astronomy, mechanics, but also the life sciences, the development of theories of matter, thinking about electrical and magnetic phenomena. That there just wasn't a text available for us.
Yeah, I mean, we could have found something if we needed, sort of starting with Copernicus, ending with Newton, or the background to Darwin, like leading up to Darwin. There's stuff available, but for sort of a broader question, if you are interested in the history of geology, or right, whether anyone was doing science in medieval Europe or the medieval Islamic world, which actually they really were, there just wasn't any single resource available. Certainly nothing that's still in print and was accessibly priced. So we put something together ourselves, which turned out to be a massive project that took most of, we did it for the first year, but we ended up, how many years did we spend revising it?
Yeah, we probably spent about 5 years testing different texts in the classroom, seeing what would work, making cuts to make reading shorter or including more text that we found as sort of necessary background. Well, as philosophers of science, we are enthusiastic about science. We like science. We're interested in not only its results, but also the activity of science in general, its sort of distinctive approach to empirical inquiry. And the fun thing is we get to ask questions about science that professional scientists don't often themselves ask and attempt to answer as part of their professional activities. So we're thinking about, well, what is it to give a scientific explanation, or what's the nature of causation? What is a law of nature? And thinking about how various people that have inquired into nature in different times and places, how they've gone about that, and what sort of assumptions that they've made about nature, or the kinds of methods that they thought would help them to answer the questions that they had, what sorts of answers that they found satisfying, what sorts of assumptions about reality, and also what values are embedded in the practices that they undertake. We're interested in all those kinds of questions about science.
And I think it's also important to remember that all of these people would have thought of themselves as philosophers. All the people in our book, which really ends in around 1900, the term science and scientist really didn't come into common use in the way that we use it today to describe the sort of things that make up the science core at Boston College until the end of the 1800s. And so almost all of the people in this book would have referred to themselves as natural philosophers. They might have been natural philosophers who had a particular interest in optics or a particular research specialty in astronomy, but they thought of themselves as natural philosophers. So it's not so much that philosophers are sort of like peering their way into this outside discipline. This is part of philosophy, and all of these people thought of themselves as such. Galileo sort of tried for years to get himself the title of court philosopher to the Medici, right? So, and Darwin's colleagues on the Beagle called him the philosopher, though I think his actual position was ship's naturalist.
That's right.
Is that right? But that's how these people thought of themselves, and so it's not really an outside field.
I think that the intrinsic value of studying the history and philosophy of science needs no defense, but there are a number of, I think, reasons that might motivate the general reader to study work like this. I think science has come to have such an important place in our culture, society, educational institutions, in political decision making, in our economy, that informed citizens in today's world need to know something about science. And we're studying science from the perspective of the liberal arts, and asking, again, a different set of questions about science and its interaction with society, its implications for how we understand our place in the universe, and thinking about the kinds of conditions under which science might best flourish, and what sorts of responsibilities we have to wield what we come to know and understand about the world in ways that can serve the public good.
I think, too, one of the things that we have learned in about 10 years of teaching the history and philosophy of science is that it turns out to be a really good way to communicate ideas about the sciences, right? For students to learn without knowing the details of what's coming in neuroscience right now, for students to understand the methodology, the fact that we are learning how we learned how to learn, really, is how I explain it to students, right? The project of understanding the natural world didn't spring fully formed from the head of Zeus in Athens. It was actually something we learned how to do a piece at a time. And we're still learning how to do it. And there's a sort of sense from history of science textbooks, or science textbooks, where you're doing problem sets that we know how to do this, that all of the basic answers are there, and we just, all we have to do is apply those to new topics. But we're actually still learning how to do this. And I think that watching the sort of, in almost real time, the process of people learning how to do this, as someone in the history of science asks a question, and then someone else asks another question, and then they refute that answer, and then they try another way of getting at it. Watching that unfold actually gives the students a truer picture of what science is like in some ways than following a general chemistry textbook.
I think it's really fun for students to ask themselves questions anew, when we're looking at how did people begin to understand what the stars are when they're looking up at the night sky, and how much would you have been able to figure out if you were living back then? Would you have been able to figure out that the moon is a big sphere up there, a big rock? What would be keeping it up there in the sky? And sometimes, buckets and buckets of water fall down from the sky. How does that work? Is there an ocean up there, and is that connected to the reason that the sky is blue? Or just setting aside the enormous amount of scientific knowledge that we take for granted today, and thinking about basic questions. What is fire? Is it a basic element? Is it a substance? Is it some combination of heat and light that's released? And what exactly is light? Is it a process? Is it a particle? Is it a wave? And one of the fun things about going through the historical development of the sciences is to see how some of these phenomena end up being interconnected in really surprising ways. So electricity and magnetism at the beginning of the 19th century seemed like unrelated
completely
phenomena.
Separate.
Yeah, and then, by the mid-19th century or so, we have a powerful unification in the work of Faraday and Maxwell that shows that electricity and magnetism are importantly connected.
And not only that, they're importantly connected, and they're connected to the phenomena of light, right?
Yes.
And this sort of ongoing interconnections and developments it's exciting to follow the process of how we got of how we got here. Well, we had to start somewhere and we had to stop somewhere. We stopped in 1900 largely because, as I think both of us tell students, there's been more science done since 1900, between 1900 and today, than was done in all the years that are covered in the book. Simply because there's so many more people doing it. There used to be a handful of scientists on the planet, right? Now there are hundreds of thousands, and it's just probably millions. Right? And now, the field has exploded. And so cutting it at 1900, while it's a little arbitrary, gave us a place where we could actually cut the size of the book, which is already pretty large.
Yeah, that's right. I think practical limitations. We actually don't stop our own classes at the end of 1900. We proceed to read Einstein's own presentation of his special and general relativities to a public audience. We talk about Niels Bohr's work in the early 20th century, the development of quantum mechanics, the elucidation of the double helical structure of DNA, by Watson and Crick, and the role that Rosalind Franklin plays in some of that research. So we do hope to eventually, I think, come out with a successor volume that would look at science in the 20th and 21st centuries. But given the sort of breadth of coverage of the volume that we have here, we couldn't hope to do justice to developments in the 20th and 21st centuries without having enough space for a separate volume.
Yeah, there's also the problem that in the 20th century, scientists are writing for an audience of each other, and they're not just writing for scientists. Astronomers are writing only for astronomers, and they're only writing for astronomers in a particular area. And so there's the level of assumptions about what you can expect your reader to know gets higher and higher and higher. It gets harder and harder to read the primary sources, basically, as time goes on. The selections get tougher and tougher. So I think when in the 20th century material, we often end up reading Nobel Prize lectures, right, instead of the original papers. Whereas in the earlier material, it's not just written for a sort of like in the know audience all of the time. It's also written in all sorts of formats. There are poems in here, right? Some of the sources, right? There are some things that read more like journal articles, just sort of like, and then I found this and I was really surprised, and then I went to bed and then I woke up and I had a new idea, right? There's a completely different sense of what the format of science should look like. It really isn't settled on until at least the middle of the 1800s. And so ending it in 1900, where we have this sort of where you're still writing to a broader community in some senses, seemed like the right place to stop.
We did also make an effort to include significant texts from Islamic science and medieval natural philosophy in Western Europe. And I think part of the choice there is to show, look, there are revolutionary developments in the sciences in the 16th and 17th century, but they're also, I think, building on work that had come before in ways that often get overlooked or forgotten if we just move from, Aristotle and Ptolemy to Copernicus and Galileo. You don't realize that some of his work is building on work that was done in the 14th century by the Oxford Mertonians, say.
And that most of the history of alchemy through the Middle Ages in the Islamic world is really what opens the door to chemistry developing in the 15 and 16 and 1700s in Europe. Without those resources and those developments, chemistry wouldn't look like what it looks like now.
Mm-hmm. Well, one of them has to do with thinking about the Earth. I think there's still a very common idea that people thought that the Earth was flat for centuries. And I think one of the things that students are surprised to find in reading Aristotle is that even way back then, not only does he know that the Earth is spherical, but they've got a pretty good estimate of its circumference.
To within about 10% of the modern value.
Yeah, it is impressive just how much people in the ancient world were able to figure out about reality. And I think that, certainly going through those texts has really increased my appreciation for the immense level of kind of insatiable curiosity about the natural world, and even the places that they go wrong are often they do so in clever ways.
Right, and really logically and logically defensible ways, right? Given the resources that they have available, they make really good decisions about what's possible and what's probable, partially because they might be interested in different questions than we are, and partially because they may or may not have the technological or mathematical resources to change it. But there's a reason that they come to these decisions, and it's not sort of, it doesn't rest in sort of this tremendous bias about us being the center of the universe, or about religious backgrounds. I'd say too, one of the other things that we find students coming into the classroom with a presumption of, and is very much a presumption, I think, in our wider culture, is that the project of science is in some ways antithetical to religion, right? In that it's going to displace religion in some ways, that the two are going to be consistently at odds. And actually, right, the more of these texts you read, the more you realize that is actually very rarely the case, right? That's the exception rather than the rule in this. Most of the people in these books are deeply devout, sometimes heretical, but in their various religious traditions, whether Jewish or Christian or Muslim, are deeply faithful people, and who think that to study God's creation is to get some insight into the divine, and that's part of the reason for their project. Someone like Newton, we kind of like to portray him as this Enlightenment sort of logician who doesn't have a lot of interest in topics of faith, in topics of faith. But actually, as we find out later that Newton is actually an Arian heretic. But an Arian heretic is someone who doesn't believe that Jesus Christ is co-equal with God. And he doesn't believe that Jesus Christ is co-equal with God because he thinks God is so awesome and so immense and so all-powerful that no one who took on human form could possibly be quite co-equal with God. That's formally heretical, but it's the opposite of atheism, right? It's a real confidence in the belief that God is important and that we are trying to understand something of what's in God's mind when we study creation. And that that's not, Newton is an isolated incident. That happens again and again and again in these texts. And it really overturns, I think, a picture of science that I think is problematic in the 20th and 21st century.
Yeah, along with that, I think we're interested in studying science and scientists, warts and all.
Yeah.
You know, I think the picture of scientists that emerges is very human in many ways. You know, they're funny in places. They're tremendously arrogant. You know, and I think one perception that one can easily get if you just have sort of snippets about Newton in the margins of a textbook is, you can forget that he wrote enormous amounts on the book of Daniel and sort of biblical prophecy. He predicted the end of the world in, I think, about
2050 or 60 or something.
Right,
It's coming up.
And, was also deeply interested in alchemy. I believe that he had to keep his alchemical shed just outside of the gates of Trinity College in Cambridge because, of its frequent association with the sort of the dark arts.
Well, I think one thing that we're thinking about in the future is how we get this into the 20th century. That's going to be a big project. But I think that's thinking about how we include some of the material in the sort of next revolutions in science, the genetic, particularly molecular biology, and the revolutions in both relativity and quantum mechanics are really important. I'm also really interested in the history of ecology, which there are some roots for in this text, but I think I'd love to include some of the 20th century science of ecology and in a version of this that came a little closer to current day.
And I think in the next work, we would like to find ways to have underrepresented groups be a stronger voice in the text, and there are challenges about trying to do that with primary source readings prior to the 19th century, but it's going to be much more, we can do a lot more there as we get into the 20th century.
Yeah, there are a handful of voices, and they're usually commentating of women and underrepresented groups from the period that we're talking about. But for the most part, these are people who weren't allowed to be educated for the most part, and it's really only at the very end of this book that we have a handful of voices emerging, and even then they're mostly commenting on others' work, which can be really interesting, but with limited space it's been tricky. There's a lot more space for that, and as the 1900 as sort of we open between 1900 and the opening of the 20th century, there's a lot more voices. I mean, everyone knows Marie Curie, but there's a lot more voices that are going to emerge, and it gets very exciting.